So, they want me to see whether x and y are parallel lines. I can't do that directly. There is no relationship that we know of whatsoever, no conjecture yet, between the two angles that are given. They aren't corresponding, they aren't alternate interior, alternate exterior, vertical, linear, they're nothing to each other. So I can't just say, hey, it works because 118 degrees plus 62 degrees is 180 degrees. So I need to put another angle in here that I can talk about. I chose this one. So this I made my angle 1. You don't have to do that. You could have chosen this angle, any of these angles. Well, almost any of these angles at least. Not this one out here. But you could have chosen these other angles and said something about how that's going to help you. What I do know for absolute certainty is whether these lines are parallel or not, these two angles, the 118 degree angle and my angle 1, are a linear pair. Remember, your reasoning is always conjectures, definitions, properties, so I have to be very specific when I'm saying this. So the angle 1 and the 118 degree angle form a linear pair, so they're supplementary. The reason that I know that is because the linear pair conjecture tells me that. So to find the actual measure of the angle, I'm going to take 180 minus 118 to get 62 degrees. So that's one part. Now I know that this, let me put it in a different color, is a 62 degree angle. The thing that draws my attention is that it's congruent with this angle. Now those are corresponding angles, so I need to use that. Angle 1 and the 62 degree angle are corresponding angles. Since they are congruent, it means that the lines are parallel. I'm using the parallel lines conjecture and specifically corresponding angles part of it. So not just the parallel lines conjecture, but the corresponding angles part. I need both of these pieces, and I need to word them fairly carefully to actually do this proof.